Differentiation, Part 3. We're going to look at the following outline: harder problems on chain rule, product rule, and quotient rule. Further derivatives and implicit function. Harder problems. Example 1. If y is equals to 5 over the square root of x squared minus 2 in bracket, find y prime. Solution. First, we apply indices to resolve the expression. We're going to have 5 bracket open x squared minus 2 all raised to power minus 1 over 2. Okay, when you apply indices. So for differentiating now, we use the power to multiply the coefficient, reduce the power by 1, times differentiate what is inside the bracket. Alright, so it will be 5 times minus 1 over 2 times the bracket, then reduce the power of the bracket by 1, minus 1 over 2 minus 1, times differentiate what is inside the bracket. You have 2x. Okay, so 5 times minus 1 over 2 will give us minus 5 over 2 times the bracket x squared minus 2. Okay, then the power minus 1 over 2 minus 1 will give us minus 3 over 2. Is that okay? Times the 2x of what we got when we differentiate what is inside the bracket that was given to us. Right? So rearranging the 2 down, we cancel with the 2 that is up. So I'm going to have minus 5x, the x outside on the other 2, bracket open x squared minus 2 all raised to power 3 over power minus 3 over 2. That becomes our answer. All right, let's look at the next example. Example 2, if y is equals to 3x minus 1 all raised to power 3, bracket close, then bracket open x squared plus 7, bracket close, find y prime. Solution. Now we're going to apply product rule here because two brackets are multiplying themselves. The product rule states that y is equals to u v prime plus v u prime. Whole v constant, differentiate v, plus whole v constant, differentiate u. That's whole u constant, you differentiate v, plus whole v constant and differentiate u. So the first bracket is u, which is 2x minus 1 all raised to power 3. Differentiate the second bracket, you have 2x, all right? Then hold the second bracket, differentiate the first bracket. You have 3 into 2x minus 1 all raised to power 3 minus 1 times differentiate what is inside, because that's chain rule. Is that all right? Okay. Now we're going to arrange our expression very well. The 2x on the first part, we'll move it to the front of the first bracket. All right. So we're going to have 2x into 2x minus 1 all raised to power 3 plus, on this side, 3 times 2 give us 6. So move it to the front of the bracket, x squared plus 7. So you have 6 into x squared plus 7, and then 2x minus 1 all raised to power 2. If you reduce the power. Is that okay? So 2x minus 1 all raised to power 2 is common on both sides of the expression, the left side and the right side. On the right side, we have raised to power 3. So we have 2x into one of the 2x minus 1, all right? Plus, on the left side, you have 6 into x squared plus 7 when you factorize both sides, like, right? Now, 2x minus 1 all raised to power 2, right? Bracket open, this other side, we're going to multiply. 2x times 2x will give us 4x squared, minus 2x times 1 will give us minus 2x, plus 6 times x squared will give us 6x squared, then plus 42, all right? So finally, rearranging, we're going to have 2x minus 1 all raised to power 2, then bracket open, 4x squared plus 6x squared, they have x squared in common, will give us 10x squared, all right, minus 2x plus 42, bracket close. That's our answer. Example 3 now. If y is equals to root x over x minus 2, in this case, we're applying quotient rule because two things are dividing. So for the quotient rule, it states that the denominator hold the denominator constant, differentiate the numerator, minus, hold the numerator constant, differentiate the denominator, all over the square of the denominator. All right. Now the numerator here is x, square root of x, which is x raised to power 1 over 2. So first we hold the denominator, which is x minus 2, right? Differentiate the top, that is x raised to power 1 over 2. When you differentiate it, you have 1 over 2, x raised to power minus 1 over 2. Minus, hold the top constant, differentiate the bottom, that's the denominator, which is 1, all over the square of the denominator. Okay? Now, remove the powers and put it in root form. We're going to have this x minus 2, 1 over 2 x raised to power minus 1 over 2 will give us 1 over 2 root x, then minus x raised to power 1 over 2. Okay? Still simplifying, x minus 2 will multiply 1 over 2 root x. It will give us x minus 2 over 2 root x minus, then x raised to power 1 over 2 will give us root x over 1. Is that okay? All over x minus 2 all square. So we'll find the LCM, all right? The LCM of the numerator, that's 2 root x and 1, will give us 2 root x. So simplify, you are going to have x minus 2 minus 2x all over 2 root x all over x minus 2 all square. Don't forget root x times root x is x. Okay? So the numerator, x minus 2 minus 2x will give us minus 2 minus x all over. When you turn the denominator, you have 2 root x all over into x minus 2 all square. Higher derivatives. If y is equals to 6x all raised to power 3 minus 5x squared plus 2x, find y prime prime. To get y prime prime simply means differentiate the expression 3 times. So we'll start with the first differentiation, which is y prime, that's dy dx. You have 18x all raised to power 2, reduce the power by 1, minus. Differentiate the second time, 2 times 5, 10x. Differentiate 2x, you have 2. Okay? Now, find the second derivative, which is y prime. Differentiate, you have 36x minus 10. Then the third derivative, which is the last one, y prime prime, will give us 36. Implicit function. Example 5 now. If x squared plus y squared equals to 5, find y prime. In this case, we call this kind of function implicit because x and y is mixed together. To differentiate this, we apply normal differentiation, but anytime you differentiate y, you add y prime to it. So differentiate x squared, you have 2x, plus differentiate y squared, you have 2y, then add y prime, multiply it with y prime. Differentiate 5, you have 0. Is that okay? Now, move the 2x out because you are looking for y prime. You have minus 2x. Divide both sides by 2y. So you have y prime equals minus 2x all over 2y. Is that okay? So 2 can cancel on both sides, the numerator and the denominator. So we're going to have minus x over y. Example 6. If x squared y minus 7x equals 15, find y prime. Now x squared y is product rule at that point. So we're going to apply product rule to dissolve that x squared y first. Then we'll do normal differentiation on the other side. So product rule, they are all x constant. All right. X squared constant, sorry. Differentiate y, you have y prime. Anytime you differentiate y, you will have y prime in implicit function. Plus, all y constant, differentiate x squared, you have 2x. Is that okay? Minus differentiate 7x, you have 7. Differentiate 15, you have 0. Okay? Now let's arrange x squared y prime plus 2xy. We'll move the minus 7 out. You have 7. Remember, we're looking for y prime. So we'll move everything out first, collecting like terms. So x squared y prime, we'll move the 2xy also out. To the other side, you have 7 minus 2xy on the other side. So divide both sides by x squared to get y prime. Let's make y prime the subject of the relation. So we have 7 minus 2xy all over x square. Example 7, which is the last example before we solve some exercise. If x raised to the power 3 plus y raised to the power 3 equals to 5xy, find y prime. Okay, solution. If you differentiate x raised to the power 3, you have 3x raised to the power 2 plus. If you differentiate y raised to the power 3, you have 3y raised to the power 2 also, but you attach y prime to it. Anytime you differentiate y, you must attach y prime. Okay, equals to all 5 out of the bracket. All x, that's product rule, all x differentiate y plus all y differentiate x. You have 1. Is that okay? Because 5 is multiplying both of them. Alright, so 3x raised to the power 2 plus 3y raised to the power 2 y prime. Okay, and we expand the bracket on this side. 5 times xy prime will give us 5xy prime plus 5y. Now we're going to collect like terms. The ones with y prime one side, the ones without y prime, we'll take them one side. So 3y square y prime minus, if you bring the other one in, 5xy prime equals 5y minus 3x square. Is that okay? So we factorize the left hand side because y prime is common. So y prime into 3y square minus 5x bracket close equals 5y minus 3x square. Divide both sides by 3y square minus 5x, so that will make y prime the subject. Therefore, where y prime will equals to 5y minus 3x square all over 3y square minus 5x. That becomes our answer. All right. Exercise 1, you solve the following questions carefully, following the examples that we have done. I would like to know how you deal with them. So solve it and send your solutions. All right. Exercise 1, you have about 8 questions, 1 to 8, and it's a mixture of chain rule, product rule, all right, and quotient rule. So solve them. Then in exercise 2, you're looking for further derivative of a function. So y prime prime. So you have just 2 questions under that part, 1 and 2. All right. So solve it. And then we have the third exercise, which is 5 question. This one is implicit function. Don't forget, for implicit function, when you differentiate y, you attach y prime to it. Okay? Anywhere you see 2 things multiplying, you apply product rule in implicit function. All right? Okay, for more of our videos, ensure to subscribe this channel. Thanks for being a part of the class.